So my topic is interoperability in Open RAN. So it's challenges, solution, and opportunities. Okay, so for our key topics, so our topic one is about network market actors and players. So when you talk about 5G Open RANs, who are those? What are the terms we use there? In terms of key topic two, we discuss about Open RAN and interoperability. Topic three, Open RAN challenges and solutions. Maybe some of those have been discussed on the previous topics in your previous lectures, but I could give you like some things that might not be discussed yet. And four is opportunities for ECE, IT, COE, CS graduates driven by 5G and Open RAN. So I want to focus on this on what's in it for us since we are studying this. What's the sense? Why we should know about 5G? Why we should know about Open RAN? What are the opportunities we could get? Or since you are the instructors, what are the opportunities for your students? Okay, since we started this Open Run Academy, so the purpose is to develop the knowledge and skills of professionals, especially the students, so we could produce more engineers and people who would be knowledgeable on radio access network and Open Run. That should be the next generation and evolution of radio access network. Okay. Okay, so let's start with the market actors players. So who are on the ecosystem of radio access network. So we have our UE mobile phone companies. So these are the companies who produce the UEs, the user equipments, the equipments that we hold. So like for example, basic UEs are our mobile phone. So anything that connects to the network to the 5G, it's called UE. So computer equipment, consumer equipments. We could think about Apple, Samsung, Huawei, um, uh, Nokia, and other UE vendors. Okay, so as we develop 5G on the network side, they also develop 5G run in the mobile, the user equipment side. Okay, so next is the equipment and hardware manufacturer. These are the hardware providers. So these are your Broadcoms, Marvell, um, Texas Instruments. So these are um, the companies, manufacturing companies that produces the hardware. So, um, like for example, Foxconn. So they are like um, not company centric. So it's not that they produce only Apple cell phones. So it's they could produce cell phones for other UE companies. So you just give them the hardware specifications. Okay, so like for example, the ONTs, the modems that we have at our home when, for example, Converge go in your home or PLDT, they have some equipment there. So it's branded as, for example, Huawei or Nokia, but the components inside, there are a lot of hardware manufacturers that manufacture those so they could like produce these ONTs. Okay, so these are the uh, hardware manufacturers. And then we have the operators, uh, telco operators who provide network services. So these are the front players who are you are dealing with whenever you would want a service, 5G, 4G service, fiber connection. So these are the likes of course, Smart, Converge, Dito, Globe, and other operators. And here in North America, we have AT&T, Verizon, uh, T-Mobile. Okay, and vendors. Of course, vendors. We have Nokia, Samsung, um, Huawei, ZTE. The upcoming Open Run vendors like Mavenir and etc. So these are the software, hardware, services, and equipment vendors to operators. So usually we partner with operators to provide them their hardware, their software, services, in terms of like even deployment and support. Okay, and then last ones are the subcontractors. They provide services in behalf of operators and vendors. So like if I am PLDT, I cannot do the part wherein the installation part of the mobile equipment. So they have some subcontractors. So for us vendors, if for example we need someone who could like um, do the backbone cabling. So we have some subcontractors and also the UE companies and also the equipment and hardware manufacturers. Okay, so there are a lot of opportunities between these market actors and players that ECE, CS, IT, and OE graduates could like explore when they graduate. Okay. Okay, so mobile-based station vendor based on market share worldwide. So this data is from Statista.com. So this data is from 2019 to 2022, and you would notice that these big vendors dominates the market. So you have Huawei, Ericsson, Nokia, Samsung competing on the market share. So since it is discussed on your previous lessons and also on your readings that right now the current deployment mode is proprietary. So meaning if operator one would deploy 5G in certain area, for example, in Nueva Ecija. Okay, so they would bid the contract for these operators, and then of course the best one wins, and then it's all package. So from the RU, DU, the cables, the SFP, everything, it's provided by the for example the winner of the bidding, for example like Huawei or Nokia. So it's end to end deployment usually. Okay, so they're not right now. There's not much space for other players. So especially the competition is like cutthroat. Uh, there are some scenarios when a certain vendor is replaced because they cannot provide what is expected or what are promised based on what they promised when they did the presentation in terms of product. There are some cases like that. So if you're not good, you lose a business. So you lose your orders. Of course, you don't have a revenue. So everyone is competing. So big vendors have an advantage in terms of like, uh, of course, they have big R&D, big workforce, and also in terms of value chain, they have the the full lineup of products that they can offer. So of course, if you could sell it by bundle, you could um, lower the price. Okay, so that's the bit of what is happening and currently the market story in terms of the deployment side. Okay, so next, mobile networks, 5G technology is one of the key enabler for AI, ML, IoT, smart cities, and transformation of industry. So uh, basically, right now, if you would assess what is happening and what is currently deployed, actually 5G is, we can say that it's ahead of uh, it's ahead of time. Okay, because if you would like read the news right now, in terms of the vendors, the big vendors, the revenues are down because the main reason is the operators are not yet upgrading because they don't see yet the value of uh, uh, upgrading to this technology because right now right we Like for example, in the Philippines, we have 4G LTE-A, which offers enough speed for the users. So sometimes in terms of like in an area, so for example, in a certain area, they don't need yet this type of this speed because they don't use much of a PIJO or like, so they're not upgrading. So, and also there are a lot of use cases that 5G could cater. So like smart cities, IoT, AI, ML, which is for the high-tech uh, countries. They have some implementations, but for other countries who is lagging in terms of deployments and in terms of technology, um, there's no need yet to deploy those uh, technologies that we have in 5G and features. Because if we are talking about like we're talking about 5G, there are certain features based on the releases. If you would read on 3GPP, we have released right now. I think the deployment is on release 15, and then we have release 16 already, and we have release 17. So constantly we are adding features and we are adding capability in terms of uh, the 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 capabilities of what your connection can do. Okay, so like network slicing, who would need network slicing? So most likely, if you have a lot of IoT IoT devices deployed in your smart cities, you would need network slicing because you would not need fast connection for IoT devices. You just need some like few bits, few megabits in terms of connection because it's constantly transmitting. So you would just need to make sure that it's a reliable connection, that it won't cut down because cut down. Um, it should be reliable so the connection won't cut because real time, of course, you would need those data. And yeah, you don't need high bandwidth. So you will need to slice your network, provide the high bandwidth for those equipments that would need a lot, and then give the reliable and low bandwidth to certain devices. Depend on need. Okay, so but right now, so of course, uh, not much had uh, needed yet. Not much deployments needed yet. So use case would drive this, and the use case would drive the demand for 5G deployments, and of course, Open Run also. But Open Run is another story. Open Run is another evolution, okay, of this technology. Okay, so I put in here some references. So in terms of 5G, we would like to study more, to read more, to understand, and to see the architecture, how it was implemented. Most likely this was already part of some of your readings, but if you're on R&D, research and development part of 5G radio access network, usually the Bible that we use is this specifications. Okay, so you can download this specification, read through it, and then try to understand the implementation, uh, we how we could implement the technology. But of course, in terms of understanding the specifications, usually it's hard to like uh, get a grasp of the whole technology and architecture by reading the 3GPP specs. But if you are working in R&D companies, usually we have architects, we have a specification architects, we have software architects who would break this down into bits of pieces until it would become a part of a feature. So it breaks down to a feature, and then it would break down to uh, code level implementation feature, and then the exact implementation would be done by the programmers. Okay, so but of course, if we would like to understand in terms of how it works. So if you would reference the specifications, usually it's like kind of like you would understand something without features. So usually it is important to have diagrams first to understand how these connections happen. So like for example, like I cannot show you the actual R&D documents, of course. So we have this event helix, which is a reference wherein you can see the call flows, how um, communication between the UE, the E node B, the G node B happens. So for example, we have here the NSA, so non-standalone. So when they designed 5G, there's two variants, the standalone and non-standalone. So non-standalone is an option for the operators who doesn't want to move right away to uh, 5G NR, the 5G new radio, but they would still want to reuse their 4G equipment. So it still can interface with the 4G core network. So you have NSA. And how does it work? How it can communicate to each other, and what are the messages being passed between these network elements? So basically, you could have the architecture view by viewing this call flow. So this is an example of the attached scenario. So when we say attached scenario, so it's the example wherein you open your mobile phone and then it connects to the network, and then the network would go the signal will go down from antenna going to your baseband unit to your core network. So these are the informations being uh, passed, received. So in terms of network programming, everything revolves on a communication between messages. So uh, if you are implementing and testing, you could also use this call flow along with your Wireshark capture to see if messages are received and what is the problem on the network. So yeah, so here's the example. So that's the attach pa lang yan. So there are a lot of procedures, but yeah, that's the basic. And you could have it here in Event Helix. So there are a lot of uh, topics that you can see and you can read here if you want to learn. Okay, and then we also have the share take note. So if the specifications are not clear enough, not uh, modularized the way you want it, so you could also use the share take note to understand each protocol stack. Like for example, if you would implement RLC, MAC, PDCP. Anyway, what is protocol stack first? Let's start with. Okay, so in terms of implementing these technologies, we have the protocol stacks for each equipment or equipment. So like for UE, you have SDA, PDCP, RLC, MAC, PI. So this translates to a source code. If you do an R&D and then you would flash it to the hardware to have a complete UE. And for Gnode B also, you have SDA, PDCP, RLC, MAC, and PI. Okay. For AMF, you have NAS. Okay, so these are the protocol layer. Each protocol layer requires implementation, code implementation. So messages are passed through between these protocol stacks. Okay, so like if you would want to learn about RLC, you could use this as a reference here. Uh, you see the messages that it handled, the BCC8, PCC8, CCH. You would know the modes, the transparent mode, acknowledge mode, the acknowledge mode. Okay, so where it's used, so like for example, transparent mode when you are calling, so the message is passed through without acknowledging or unacknowledging, because of course this is real time. Uh, so that's why sometimes if you're talking to someone, message is garbled. because you need to like receive the message pass. So the message should pass the network real time, because of course you would need the message. So acknowledge mode, for example, you would want to download the picture. So in picture, if sent from point A to point B, when the receiver point B sees the picture, we don't want it to be garbled, right? So it should be acknowledged. So there, uh, acknowledge mode, the packets are segmented, and then it was there's a certain logic to make sure that everything is placed well, and if something is lost between the time that it was sent, the node, the receiver would send a message that I don't receive it. So that's the simple logic of it. But in terms of implementation, it's quite complex, because if you would see, there's packet segmentation here, blah blah blah, everything. There are formulas that you would implement. Okay, so that's protocol stack for you in terms of implementation. So it would took a lot of people to implement those protocol stack. R&D people, coders, developers, architects, etc. Okay, so but that's how it's done. So we have run, AI, everything, specifications. So let's move to Open Run interoperability. So this is the maybe more easy part. Open Run in a nutshell is about disaggregating software from hardware and having an open interfaces to allow vendor interoperability on Open Run deployment. So to explain Open Run or interoperability in a nutshell, we could imagine the time when we have, in terms of PC, like the time of IBM and Apple, right? So if you would buy IBM, everything is IBM. If you buy Apple, everything is Apple. Okay, so you cannot uh, go to Gilmore, buy a motherboard, and then place it to your IBM computer during those days. You cannot buy a video card on Gilmore and then put it in your Apple computer during that time. And then Microsoft came, and that breaks the traditional system. So hardware is disaggregated with software, and interoperability between PC components are also broken. So you could buy uh, NVIDIA, your video card, and then ASUS as your motherboard. Your For your network card, you could have Broadcom. So it became disaggregated, and also the software are disaggregated. So you could have Windows, you could install Linux, you could install other softwares, and it produces a lot of companies and a lot of vendors. So it's disaggregated. Okay, so interoperability means that these components, your RU, your DU, your CU, your core network, can have different vendors because you have an open interfaces. So your front hole. Um, so basically, it's hard to understand if two people are talking, if the one is speaking Tagalog and the one is speaking in Chinese. Of course, maybe uh, you can understand the context, but the exact word, the exact message, it's hard to understand. Okay, so by having this open run, the purpose is for these components to understand each other, even though they are different uh, nationalities. So like You have here Huawei, you have here Nokia, you have here Ericsson. So if they would all comply to the Open RAN standards and Open RAN specifications, they would use the common implementation for Open Threshold. If you would put your, pag sinalpak mo, yung SFP cable, if you put on your SFP cable here and here, they will understand each other. So sometimes when I talk about Open RAN with other uh, engineers or other people who doesn't who does not have familiarity yet on Open RAN, the common notion is usually the concern is they're thinking about that it's like an open source. No, it's not an open source. The vendors will still develop their own products. It's just that they would make sure that their product can interconnect with other vendors. And also, if I'm a hardware company, I should make sure that my hardware is disaggregated with the software. Okay, so like for example, right now it's happening on our CU on the centralized unit. The hardware that we deploy on our data centers, for example, I would buy HP. So I would buy HP server, and then my software, my OS is Linux. Okay, and then on top of that Linux, I would also install some softwares that would be specific on my need. Okay, so it's not vendor dependent. So unlike right now on 5G deployment, what we have is if you would buy what I've discussed earlier, if you would buy like for example Huawei, RUDU software, even transmitters, even cables are part of the bundle to make sure that everything is working properly and everything is, of course, there are some advantages of that. Isa lang yung kausap mo. And then if there's a problem, you just have one person to point to. Okay. So you also have most likely this has been also showed to you. So you have your Open Run specifications. You could download it here and then read the specification and understand it, implement it into code, and also develop your hardware. Okay, so yeah, so you also have the specification there. And if you would want to understand more Open RAN based on Nokia's perspective, so you have this link. So Open RAN explained. And I think Nokia also would release some training materials regarding Open RAN. Right now, as I know, we have the trainings for 5G. So these are good materials that you could read to understand more about 5G and radio access network. Of course, before going to Open RAN, we should understand first the RAN 5G, because it's not replacing 5G. It's just an evolution way of the technology. So you would have still the same speed, but it's interoperable. Okay. Okay, let's move. Okay, so here you have the traditional RAN, 5GB RAN, and Open RAN. So these are the graphical view of I put it here so you could see the actual equipments that was interconnected, so you could have the RAN and the difference between these. So of course the main difference is the in terms of Open RAN, you have the easy pre, the open front hole, and the mid hole open, so it could be interconnected to each other. Okay, so have your antenna, you have your radio unit, distributed unit, and you have your centralized unit. But in actual implementation, let's see. Okay, so that's, you have your RU. This is your RU. You have your DU. So this is your DU. And you have your CU. This is your CU. And core network, what you would see in core network is also looks like this centralized unit. So it's same servers, look like the same server. So I'll show you the actual, let's search for pictures because I can show you our laboratory. It's not allowed. Okay, for RU, you have your RF antenna and you have your RRU here interconnected by a cable, and then you have your RRU. It would go down to the boxes on the lower part, on the ground, the tower, and you would have the distributed units. So in terms of distributed units, what you could see inside the box are, so here's what's inside the box below your towers. So this is an air scale. So you have your ASIC and your ABIL here. So the connection from RU would connect through QSFP going to here. So you just connect cables here, and also going to your CU, you would have these connections. So it's connected via QSFP, SFP cables. In terms of your synchronization, your GPS connected here via HDMI, and your crop port connected via RJ45. So that's your distributed unit, your centralized unit, install and rack. So if you would go to the data centers, you would see a lot of those. So yeah, so it's good for like universities could arrange some visits and tours for students so they could see this device in action, in actual like operations. So they would like be more interested to learn and to understand more about Open Run, about these equipments and everything. So just wanted to show that to you. So please, we have a reference. Okay, so for open front hole functional descriptions, so you have your control plane, user plane, synchronization plane, and management plane. So for control plane, so it would be about the scheduling commands for both downlink and uplink data transfer. For user plane, this is the actual user data being exchanged from your DU and your RU, and your synchronization plane for your timing and synchronization data. So this is important in terms of network communication because of course you should be synchronized. If you're not synchronized and timing is bad, the data that would receive on, it's either it would time out, the data won't be received, or uh, the data is incomplete. Okay, so synchronization is important, and then management plane, of course. So this is for managing the equipment. So you have here your configurations run through the management plane. Okay, so some drivers and factors why operators are looking into Open Run deployments. So this is um, the reason sold on paper why would we would need Open Run. Okay, so capex and opex reduction. So more vendors and competitions will drive software, hardware, and services lower. So this is for the operators, and this is for the consumers. So imagine that my example before. So the IBM and Apple days, and then sino lang ba nagkakaroon ng IBM, sino lang ba nagkakaroon ng Apple computer. So during that time, those who can afford, who have spare money can buy, but common people cannot. So when the interconnection between hardware becomes open, and then the software is open, and also of course uh, some are some use some pirated software, so they don't have to spend. Okay, so yeah, it lowers the price. Okay, and also it uh, gives birth to a lot of companies who produces hardware and software. So the market becomes wide, the competition becomes steeper. So competition means network vendors could lower their prices. Because as we see right now, as I showed you, uh, there are not a lot of players right now. So uh, yeah, so hopefully we could realize it. But right now, if you would talk to operators, they would say that show me first the actual saving. So like bago ko gawin yan, pakita mo muna kung magkano yung matitipid ko. Baka sumakit lang yung ulo ko dyan kaysa makatipid ako. Okay? So right now, a lot of operators are in wait and see mode, and but some big players are starting to adapt and try to do some small deployments to check the benefits of Open Run. Mga early, that's what we call them, the early adapters. Okay. And then a supply chain issue brought about by events. So like, for example, we had pandemic, chip shortage. Operator has other options as they are not locked into a specific vendor. They can choose other suppliers that has better time to market, deployment, and has buffer stock. Disaggregating hardware software might result to birth of companies which develop run component. It does not need to be an end-to-end company. Okay, so like when we had a pandemic, we got a supply chain issues. So during that time, it's hard to secure all of orders. Vendors are in like are grappling to have stocks on their warehouse to provide equipments to operators, because during that time there's a rapid deployment of network, because there are a lot of uh, working from home, network is essential and everything, all that stuff. So there's a pandemic. So if you're locked with a certain vendor, if their manufacturer had a lockdown, they cannot provide you the equipment. So you are forced to find another contract again. While if you are in Open Run, you could just announce that we need an antenna to all vendors, and everyone who has available supply could just bring it to you and sell it to you, and then you plug it in to your front wall cable and everything will work fine. Okay, so that would be the biggest advantage, because we don't know, right? There's a lot of computation going on in terms of like in terms of chip production. There's a bottleneck there. So up until now, we have a shortage. And also geopolitical situation. So it's examples regulating regulators banning product due to security or other issues. They can easily switch if technology is multi-vendor. So of course, we have a big brother always, the government. If regulators would decide that there are some security issues to this network vendor, they could just say that by next year you should be using other equipment. So if you are not multi-vendor lockout, you could easily switch with Open Run. Use case drives implementation and adoption of technology. So this is what I mentioned before. Use case is a key in terms of adapting, kasi bakit ko gagamitin yan kung wala namang bibili? Bakit ko bibilin yan kung hindi naman magagamit? Okay, bakit ko sisirain yung gumagana pa, satisfied pa naman yung customer ko, hindi naman siya nag-ano. So we need just use cases. We need like smart cities. We need IoTs. We need to show the benefits of having those. We need to show the benefits of having sensors in our car. Okay, so this is the key driver, one of the key driver. And then leading vendors are also invested in this technology and evolving to adopt openness in network. Okay, so one best indication that Open Run will fly is the leading vendors are in the boat, and also they are leading the boat. So they are not like uh, passing this opportunity to develop Open RAN. They want to be in it. So ibig sabihin, they see something and they see it as part of the evolution of the network. Of course, 5G, we would have 6G, right? We would have 7G, but in terms of Open RAN, openness of the network equipment, disaggregating software from hardware, they see some value. So Nokia, Huawei, Ericsson, everyone has some press releases and some trials. Okay, so it's a good indication that this technology will fly. Okay, topic 3, Open RAN interoperability challenges and solution. Okay, challenges. Multi-vendor approach introduces some complexities to testing, integration, deployment, and support and maintenance. Okay, so if you would deploy different vendors right now, operators are used to talking to a single vendor. So if you have multiple vendors, mas marami kang kausap. The contracts would be more complex. Okay, in terms of testing, how you would test right now, the current practice is okay. You win the contract, and then you would do a demo, you would do a testing, and also you would do the deployment, and then we approve. Okay, so right now, if you have multi-vendor, who would test? Okay, so is it a joint effort between vendor A, vendor B, and vendor C? So more vendors, more complexity. Okay, more if you would use disaggregated software from hardware, more problems, because sometimes if you encounter issues, the first question is it a software issue, is it a hardware issue, and another contention is it a problem from vendor A, is it problem on vendor D, is it problem on the open front tool? So there's a lot of like things to consider when you are on multi-vendor approach. Oh, of course, also in integration, in terms of deployment, in terms of support. So if you would like to investigate a certain issue, so most likely the vendor would be defensive. Ay, hindi sa amin yan, dun yan sa kabila. Okay, kasi na-receive namin yung message. Okay, so okay yung product namin. Okay, so in terms of maintenance also, so most of the time there are subcontractors to handle all the maintenance. So with Open RAN, are we like talk to other multiple subcontractors or single maintenance that could provide services with all of skills and knowledge on all its products. Okay, so those are the challenges. Of course, there are challenges, but there are some solutions, and these solutions uh, present some opportunities for us. So solutions. So we could have simulators. We can use some automation tools. We could use predictive AI. Our RIC, the intelligent controllers, should be intelligent enough to know what is the problem. Multi-vendor integration experts, interworking policy between vendors on support and maintenance. Okay, so simulators, you don't need to, like before deployment, vendor A could simulate the messages passed through equipment A to equipment B. Okay, and then automation tools, you could like without uh, the uh, actual tester or actual equipments, you can automate the test. Okay, and of course predicted AI and everything. Okay, so solutions. So we have opportunities, and for ECE IT Co ECE CS graduates driven by 5G and Open RAN. What's in it for us? What we are here, so of course to keep us updated, and our opportunities. Open RAN is a new technology. No new technology introduces some complexities, and every problem has a solution, and that give us opportunities. So not only for instructors, for students, and for professionals here in the Philippines. Okay, so for technology development, the players in terms of R&D, so for specifications, we could have software, hardware architect, solution architect, uh, Scrum Masters. For the development, we have software, hardware development, product owners, product managers, Scrum Masters, tech lead, etc. For testing and integration, we have integrators, software tester, automation experts, DevOps engineer, release manager, etc. So that's the ecosystem of R&D. So for the software that usually used when developing this technology, radio access network, so the closest to hardware is C++. So in terms of the upper layer, the upper layer part of the protocols, you also use Java. In terms of release automation, you have Python. In terms of deployment, you have Kubernetes, um, OpenShift, Jenkins. So these are the things that we need to learn or um, make sense to to study and to learn. Okay, and for technology deployment, after you develop the specification, development, integration, after that you would market and also sell and deploy your product. So you have your pre-sales, you have your sales account, tech experts, network engineers, technical teams who will do the demos and the POCs. And post sales, once you already sold your product, you have your project managers, technical expert, network engineers, integration deployment expert, support and maintenance. And for support and maintenance, it's another part wherein after sales market wherein you need to support the equipment. So for example, if you have some problems, they would call support, maintenance, and the specialist who would handle this. Okay, so these are other areas that would be open and also will add to the jobs that we could have when we are in 5G run and open run. And also one thing to note that I would also want to mention is I have discussed about call flows. Okay, so it's good to train also our students to read logs because once you're into R&D and development and also on technical support, usually you work with logs, software logs, hardware logs, error logs, debug logs to investigate and to check what is happening and what has happened. Because I'm just mentioning this because once I shift from academe to industry, this is one of my first struggle reading logs because usually at school we don't read logs. We just have like the compile errors, but in terms of investigating logs, I'm not used to it, so I have to print out a lot of uh, these logs and then yeah, and then it's investigate.